Good evening, everyone. Good evening, everyone. This is Dr. Ankit. I hope I am audible. Good evening, guys. Am I audible? Shall we start today's session? Today I'll be discussing about the properties of enamel. So, we cannot cover the entire enamel in one session of 1 hour, right? So, today we'll be discussing about the properties of enamel. So, let's first start with the basic introduction of enamel. So, what is enamel? What is enamel? Can you tell me what is enamel? Why is enamel called enamel? What is enamel? So, basically, enamel is anything that is protected. Basically, it is a protective layer. Very good evening, Shweta. So, enamel is a protective layer, right? So, since it protects the entire tooth structure, the coronal part of the tooth, that's why it's called enamel, right? And enamel is a very unique tissue. Now, why is it a unique tissue? It is a unique tissue. Why? Because unlike other tissues, it does not retain its formative cells. So you can take, for example, any dental tissue, be it dentine, be it cementum, or be it any other tissue. The formative tissues, they are retained throughout the life. But in case of enamel, the formative tissues are lost, or the formative cell is lost as soon as the enamel formation is completed. Isn't it? The formative cell is lost as soon as the enamel formation is complete. And which is this formative cell? It is the ameloblast, isn't it? So ameloblast is lost as soon as the enamel formation is complete. What else? So apart from the loss of formative cells, enamel also does not have, it lacks innervation, and also it lacks blood supply, or you can say that it lacks nutrition, source of nutrition, right? So it lacks any source of nutrition, it lacks innervation, and also does not have any formative cells. So for that reason, enamel is also known as a non-vital tissue, isn't it? It is also known as a non-vital tissue, isn't it? So can you tell me which is the hardest tissue of the body? Which is the hardest human tissue? Hardest tissue in the body. So which is the hardest tissue in the body? Let's say the options are enamel, dentine, cementum, and bone. So which of these four is the hardest tissue in the body? So what will be your answer? Our answer would be the hardest tissue in the body is enamel, isn't it? The hardest tissue is the enamel. Now, instead, if I asked you which is the hardest vital tissue. So instead if I asked you which is the hardest vital tissue, what would be the answer? Let's say these are the options, right? These are still the options. So what would you say? Which is the hardest vital tissue? Which is the hardest vital tissue? So the hardest vital tissue, definitely enamel is not the answer, isn't it? Because enamel is non-vital. It does not have formative cells. It does not have a source of nutrition. So it is considered non-vital tissue. So which is the hardest vital tissue? The answer would be dentine, right? So dentine is the hardest vital tissue and enamel is the hardest tissue. Clear? So why is the enamel hardest tissue? So as I just said, we'll talk about the properties, right? So let's first start with the physical properties. So hardness. So when we talk about hardness, enamel is the hardest tissue, isn't it? Enamel is the hardest tissue, though it is non-vital. Now why is it hardest? First of all, it has highest mineral density. So mineral density is highest. The hydroxyapatite, or you can say the inorganic content. The inorganic content of enamel is approximately 96% by weight and 88 to 90% by volume, right? So it is 88% to 90% by volume and 96% by weight. So it is highest amongst all the hard tissues of the body. So first of all, inorganic content is highest. Second, the hydroxyapatite crystal is the largest. And third, this hydroxyapatite crystal is tightly packed. So tightly packed that the space between these hydroxyapatite crystals, let's say these are individual hydroxyapatite crystals, right? These are individual hydroxyapatite crystals. So the space between these crystals, this is space between the crystals is less than 5 nanometers, right? This space is less than 5 nanometers. They are so tightly packed. So because of these factors, enamel is the hardest tissue. Now obviously when it is the hardest tissue, it will have some disadvantages. Now what are the disadvantages? The disadvantage is that it is brittle, right? It is brittle, though it has a very high modulus of elasticity. Now what do you mean by modulus of elasticity? Basically, modulus of elasticity means stiffness, right? So enamel is a stiff tissue, it is a hard tissue, and it is a brittle tissue, right? So one must imagine that since it is brittle, it might fracture under occlusal loading, but that does not happen, right? Why? First, so the question is, why does it not fracture under loading, or you can say occlusal loading, right? Why does it not fracture under occlusal loading? Since it is brittle, it must fracture, right? But then why does it not fracture? Because first of all, it has high modulus of elasticity, and second, it is supported by a flexible dentine, isn't it? So the dentine is flexible, or you can say that the dentine is a viscoelastic tissue, right? A viscoelastic tissue, that is, it absorbs these stresses and it gradually releases them, isn't it? Good evening, Deepa. So why does the enamel not fracture under occlusal loading? Because first, it has high modulus of elasticity, or you can say it is stiff and it is supported by a viscoelastic dentine or an flexible dentine, right? So since it is viscoelastic, it absorbs the occlusal loading or occlusal force and it gradually releases it, right? So there is no sudden change in the force that is experienced by enamel. So that's why the fracture of enamel is prevented usually, right? So as I just said, it is the hardest tissue. It has high modulus of elasticity and it has high brittleness as well. What else can you say are the properties of enamel? So apart from hardness, let's talk about its thickness. So the next property we're going to discuss is its thickness. So do you think the thickness of enamel is uniform throughout, as in starting from the cervical margin to the occlusal surface or the incisal edge? Do you think its thickness is uniform or do you think its thickness is variable? So whether its thickness is uniform or variable, यूनिफॉर्म होगी या वेरिएबल होगी. So which of these two is correct? And the answer is that it is uniform. It is uniform in primary. It is uniform in primary. And it is variable in permanent. So the thickness is variable in permanent dentition and it is uniform in primary dentition. So in case of primary dentition, the thickness of enamel throughout, let's say this is the dentine and above it we have enamel, right? So the thickness of enamel throughout is approximately 1.3 to 1.5 millimeters. Whereas in case of permanent, the thickness is variable and maximum thickness is at the occlusal surface or the incisal surface and minimum thickness is at the cervical margin. So at the cervical margin, the thickness is approximately 0.7 millimeters. At the cusp tips, it is approximately 2.5 millimeters, and on the proximal surfaces or on the buccal or lingual surfaces, it is approximately 1.5 millimeters, right? So the thickness is variable in case of permanent and it is uniform in case of primaries. Apart from this, there is a variation or variation of the thickness within the tooth or within the arch. For example, as we move distally, right, from first molar to third molar, the thickness increases, right? Thickness of enamel increases as we move distally from first molar to the third molar. Also, in a same tooth, the thickness of enamel is more on the supporting cusps as compared to the guiding cusp. So the portion of tooth that is under stress will have an increased thickness of enamel as compared to the portion which is not under stress, right? So let's say these are the occluding molars. This is the mandibular molar and let's say this is the maxillary molar, right? So this is the maxillary palatal cusp. This is the maxillary buccal cusp. Mandibular buccal cusp, isn't it? So the maxillary palatal and the mandibular buccal cusp, these are the supporting cusps, isn't it? These are the supporting cusps. So on maxillary palatal and mandibular buccal cusps, these have more thickness as compared to guiding cusps. So which are the guiding cusps? In the mandible, it is the lingual cusp and in the maxilla, it is the buccal cusp. Clear? क्या आप लोगों को सब कुछ समझ में आ रहा है अभी तक जो कुछ भी मैंने बताया? Guys, are you able to follow? अगर कहीं भी कोई भी डाउट हो तो आप मुझे पूछ सकते हैं, आप मुझे रोक सकते हैं, राइट? So I hope whatever I've taught so far is clear, right? So let's move forward. So what we have done is hardness. We have talked about hardness, brittleness, then its thickness, isn't it? The thickness is variable and uniform depending on the denture that we are dentition that we are considering, right? Then let's go to the optical properties. The optical properties of enamel. Optical properties of enamel. So do you think enamel is an opaque tissue or is it a translucent tissue? Is enamel an opaque tissue or is it a translucent tissue? So enamel is translucent, not just translucent, it is also fluorescent. Isn't it? It is translucent and it is fluorescent. So when we say that it is translucent, what do you think its color would appear like? Its color, how would the color of the enamel appear since it is translucent? One must imagine that since the dentine, underlying dentine is yellow, enamel must appear yellowish, isn't it? But what actually happens is that let's say this is the dentine and then above it this is the enamel. So as the light passes through enamel, it gets internally reflected, right? It gets internally reflected. It does not come out, right? It does not reach back to the observer's eye. So what the observer sees is white color. And this all happens when the enamel is new, when the tooth is new, when the enamel is not 100% utilized, or when the enamel is not yet fully mature, right? So initially when the tooth is newly erupted, the tooth appears more whitish. The tooth appears more whitish when it is newly erupted. So we can describe the appearance as yellowish white or greyish white. But as the tooth ages, the enamel, it becomes more mature. Its mineralization increases, right? With age, the mineral content increases. The mineral content increases and the tooth becomes, or the enamel becomes more mature, right? So the enamel becomes more mature, and as the enamel matures, its translucency increases, right? And when its translucency increases, let's say this is the dentine and this here is the enamel. So when the light passes through the enamel, it returns back to the observer, right? It returns back to the observer. So now we are clearly able to see the underlying yellowish color of the dentine. So as the enamel ages, it becomes more yellowish. So initially it is more towards white, and as it ages, it becomes more towards yellow. All because of the increase in the mineral content of the enamel, or all because of the increase in the maturity of enamel, right? So someone might ask you, what is the refractive index of enamel, since we are saying that it is a translucent tissue? So what is the refractive index of enamel? What is the refractive index of enamel? The refractive index of enamel is somewhere around 1.62, right? Sometimes this value has been asked in some of the questions, some of the papers, that what is the refractive index of enamel. So we can clearly just say that it is 1.62, right? And it is a translucent tissue. So next we said that it is a fluorescent tissue. But before we go to the fluorescent tissue, I would also like to tell you about the color of the primary tooth, right? So there might be some difference between the color of the primary and the permanent tooth, and you must have experienced it that the primary dentition, it appears a bit whiter as compared to the permanent dentition, isn't it? So the primary, they appear more white. They appear more white in comparison to the permanent dentition, isn't it? So why does that happen? It happens because, so if you apply the concept that we have just discussed, the mineralization concept, you would realize why the primary tooth appears whiter. The reason being the primaries, they are less mineralized as compared to permanent dentition. So primary teeth are less mineralized as compared to the permanent dentition, and that is why they appear more white, and that's why their appearance has been described as China white. Right? Their appearance has been described as China white. Is it clear? Do you have any doubts? क्या आप लोगों को कुछ पूछना है, कोई डाउट है, कोई ऐसी चीज जो समझ ना आई हो? तो फिर आगे बढ़ते हैं, राइट? सो दिस वाज अबाउट कलर. नाउ लेट्स गो टू दी fluorescence, next property. Fluorescence. So enamel is also a fluorescent tissue, right? It is a fluorescent tissue and it absorbs light in UV range and it emits light in blue range, right? So it will absorb the UV light and then it will emit the blue light. That's why in a newly erupted incisor, particularly, right? In a newly erupted incisor, its incisor edges, they would sometimes appear bluish, right? In case of a newly erupted incisor, let's say this is a newly erupted incisor. Now, since in case of a newly erupted incisor, the incisor edges are not yet worn out, isn't it? They are not yet worn out. Let's say this is the dentine and the incisor edge, here there is no dentine, isn't it? There is just a double layer of enamel present, the labial and the lingual layer of enamel. So light can easily pass through here, isn't it? And the fluorescence can be easily seen at the incisor edges. So incisor edges typically appear bluish. So the incisor edges, they typically appear bluish in a newly erupted tooth, right? So this was about fluorescence. Now, can you tell me which factors increase the translucency of enamel and which factors make it more opaque? Factors affecting translucency of enamel. So the first factor that would affect the translucency of enamel is hydration. Isn't it? Hydration. You must have experienced it in your clinics that when you dehydrate a tissue or when you etch a tissue, it becomes dehydrated, it becomes more opaque, it appears more opaque, isn't it? And when you rehydrate it, it again appears more translucent. So hydration affects the translucency. A dehydrated tooth appears opaque. Dehydrated tooth appears opaque. And when it is rehydrated, it again appears translucent, isn't it? It again appears translucent. Are you able to follow this? कहीं भी कोई confusion है तो आप पूछ सकते हो, right? So hydration affects the translucency. So which other factor affects the translucency of enamel? So the second factor that would affect the translucency of enamel is the incident light or the wavelength. Incident light, that is the light falling on the tooth, right? In case of a red light, so when a red light is falling on the tooth or the enamel would appear more translucent. Right? So in case of a red light or under the red light, the tooth will appear more translucent, whereas under the blue light, that is shorter wavelength. So in case of a longer wavelength, that is red light, it appears translucent, whereas in case of shorter wavelength, that is under blue light, it will appear more opaque. Right? It appears more opaque. So these are the two factors that affect the translucency of enamel. Clear? So this was about the optical properties of enamel. So next, do you think that enamel behaves like a semi-permeable membrane? Do you think enamel can behave like a semi-permeable membrane? We have initially discussed that enamel, which is made up of hydroxyapatite crystals, has a space of less than 5 nanometers between these crystals, isn't it? So space between crystals is responsible for semi permeability, right? That is responsible for semi permeability. And how much is this space? We have already discussed that this space is somewhere around 5 nanometers. It is not even 5 nanometers, it's less than 5 nanometers, right? In total, in a newly erupted tooth, right? In a newly erupted tooth, the pore volume, that is the volume percentage of the total porosity of enamel, is approximately 5%, right? And this pore volume decreases as the tooth matures. So the semi-permeability or the permeability of enamel decreases with age, right? The permeability of enamel decreases with age, right? So as the tooth ages, the permeability of enamel decreases because it becomes more mineralized. So this pore volume, 5% pore volume, whatever the porosity is present, this represents the water content of enamel, right? Basically, these pores, they are occupied by water, right? These pores are occupied by water, and this water, as the tooth matures, is replaced by hydroxyapatite, or you can say mineral content, right? So it becomes less and less permeable with age. Now, can you tell me what is the specific gravity of enamel? Now, what is it? Specific gravity? Basically, it's just the relative density of enamel, right? Relative density of enamel in relation to water, right? So density of water, let's say, is 1. So in comparison to water, what is the density of enamel? So the density of enamel is somewhere around 2.9 to 3, right? So usually this is the figure that you need to remember, 2.9. Is it clear? So enamel is approximately 3 times heavier as compared to water, right? Is there any confusion or is everything clear? क्या आपको सब समझ में आ रहा है? कोई ऐसी चीज जो नहीं समझ में आई हो या कंफ्यूजन है कहीं? In any of the properties of enamel, if there is any confusion, you can ask me. I hope I am not too fast. आगे बढ़े. आगे बढ़ते हैं फिर, है ना. So I've told you about its physical properties, its optical properties. So let's discuss a bit about its chemical properties, right? Chemical properties. So when we say chemical properties, basically enamel is composed of inorganic, organic, and water. So maximum is the inorganic content, isn't it? Maximum is the inorganic content, and usually when we talk about the composition, we usually it is, or you can say it is considered, it is that the composition is represented in weight percentage. If at all we need to talk about the volume percentage, we need to specify, right? So if it is unspecified, it is considered that it has to be weight percentage. So if I simply write here that it is 96% the inorganic content, then it is understood that 96% is weight percent, right? It is weight percent, or you can say it is 88 to 90 volume percent. So in case of volume percent, we need to specify. In case of weight percentage, we do not need to specify, right? Organic. So the organic content of enamel is approximately 1% by weight and approximately 4% by volume, right? Its water content is approximately 3% by weight and approximately 6 to 10% by volume, right? 6 to 10% by volume. So this is the composition of enamel. So sometimes they will ask you about the volume percentage or the volume composition of a particular component, right? But usually they'll ask you about the weight percentage. So 96 is inorganic, 1% organic, and 3% water. But same things when asked in volume, it changes, right? So what is the structure of hydroxyapatite crystal? What is the structure of hydroxyapatite crystal? It is basically hexagonal, isn't it? It is hexagonal, and it can be represented as Ca10 PO4 whole 6 OH2. So this is the formula of the hydroxyapatite crystal, and it is universal. That is, be it the hydroxyapatite of bone or cementum or dentine or enamel, the formula will remain same. This is the formula for hydroxyapatite crystal of any hard tissue, even calculus, isn't it? So this is the hydroxyapatite, and this is the chemical formula of hydroxyapatite. So how else can we represent this formula? Do you think we can divide this entire equation by 2 so that it becomes Ca5PO4 3OH, right? We can divide this formula by 2 so that we get Ca5PO4 3OH, and still it represents hydroxyapatite, isn't it? How else can we write this formula? How else can we write this formula? So do you think the formula that I have written here is same as this formula? If you balance the individual elements, so for example, we have 10 calcium here, isn't it? So 3 multiplied by 3 is 9 plus 1, and we still have 10 calcium, isn't it? 3 multiplied by 2, and we still have 6 phosphate ions. Similarly, 2 hydroxyl ions. So yes, the formula is balanced, isn't it? And even this formula, it represents the hydroxyapatite crystal. So these are some of the ways in which the hydroxyapatite crystal can be represented, right? So obviously in exam they won't ask you a straightforward formula. Sometimes they would ask you this complicated formula, isn't it? So you can just remember that there has to be 10 calcium, 6 phosphate ions and 2 hydroxyl ions, right? So what is the structure of the hydroxyapatite crystal? Basically it is hexagonal in shape, so it would look like this. So this is what it would look like. So the outermost shell or the outermost layer is formed by calcium. The inner circle is formed by calcium and phosphate, right? It is formed by calcium and phosphate. I am simply writing P, but it is PO4, right? It is PO4, phosphate ion. And at the center we have hydroxyl ion, right? At the center we have hydroxyl ion. So at the core of the crystal we have hydroxyl ion, and at the periphery of the crystal we have calcium, right? This is the structure of the hydroxyapatite crystal. Is it clear? So this was about the properties of enamel, right? This was about the properties of enamel, and now we can discuss some MCQs. I have some MCQs for you, so we can discuss those MCQs. But before we go to MCQs, do you have any doubt that you would like me to clear? Do you have any doubt so far? So let me also tell you about ionic substitutions, right? Since we have already discussed about the structure of the hydroxyapatite, let's also see the ionic substitutions. So when we talk about ionic substitutions, there is one substitution that we all are very familiar with, isn't it? And which is that substitution? It is the substitution of fluoride. It is the substitution of fluoride, or you can say it is the substitution of hydroxyl by fluoride. So fluoride, it substitutes hydroxyl ion in the core of the crystal, isn't it? And it stabilizes the crystal. It stabilizes the crystal, isn't it? It stabilizes the crystal, and therefore it increases Carey's resistance. It increases Carey's resistance. Basically, it is beneficial for the tissue, for the tooth, isn't it? And its concentration, it increases from DEJ to surface, right? Its concentration increases from DEJ to surface. So maximum fluoride is on the surface and minimum is at the DEJ. Opposite to this fluoride ion are two other ions, magnesium and carbonate, isn't it? Magnesium and carbonate. Now magnesium being a positive ion, it would replace a positively charged ion, that is calcium, and carbonate being a negatively charged ion would replace a negatively charged ion, that is it substitutes both phosphate and hydroxyl, but it commonly substitutes phosphate. It can substitute both phosphate and hydroxyl, but it commonly substitutes carbonate. So what happens is that both of these magnesium and carbonate ions, these will destabilize the crystal, isn't it? So both magnesium and carbonate they destabilize the crystal. So basically, it becomes increased caries prone. So the tooth becomes increased caries prone. Thankfully, their concentration is maximum at DEJ, right? Their concentration, it increases from surface to DEJ, right? So they are maximum at DEJ and minimum at the surface. So that is a positive, right? Also, in a newly deposited hydroxyapatite crystal, deposited hydroxyapatite crystal is rich in carbon. So as I just said, with the carbon and magnesium, they are maximum at DEJ. So the tooth or the enamel, it starts to form at the DEJ, right? The enamel starts to form at the DEJ. So first hydroxyapatite crystal will be deposited at DEJ, and the first crystal that is deposited when it is still immature, right? It is rich in carbonate, and that's why it is also sometimes known as carbonatoapatite. So instead of calling it hydroxyapatite, we often call it carbonatoapatite because it is rich in carbonates. So if someone asks you which portion of a hydroxyapatite crystal is more prone to caries, now since the core or the first formed portion of the hydroxyapatite, let's say this is the first formed portion of hydroxyapatite, isn't it? This is the first formed portion of hydroxyapatite, and when it is formed first, after that it matures, isn't it? After that it will mature. So obviously more of hydroxyapatite crystals are deposited on and around it, isn't it? But these later deposited crystals, they are hydroxyl rich and hence they are hydroxyapatite. So they are caries resistant, but the initial portion is caries prone. So which part of this hydroxyapatite crystal is caries prone? Is it the core or is it the periphery? The answer would be it is the core, right? So the core is caries prone, right? The core is caries prone. Is it clear? I hope the topic is clear. If there is any doubt, you can ask me. दीपा, श्वेता और भी जो बच्चे हैं अगर देख रहे हैं कोई, अगर आपको किसी भी तरीके का कोई डाउट है इस टॉपिक में तो आप मुझसे पूछ सकते हैं. नहीं तो थोड़े बहुत एमसीक्यूज और हैं मेरे पास, जस्ट टू reinforce the concepts that we have just discussed, right? तो ऐसा कुछ नहीं है कि मैं तुम्हारा एग्जाम लेने वाला हूँ या कुछ है, मिलकर के अपन डिस्कस करके सॉल्व करेंगे, राइट? बट ऑल आई एम आस्किंग यू इज टू पार्टिसिपेट. तो जब भी एमसीक्यू कोई आए तो प्लीज ट्राई टू पार्टिसिपेट कि हाँ ठीक है क्या आंसर हो सकता है. गलत जवाब भी दोगे चलेगा, कोई प्रॉब्लम नहीं है. ऐसी कोई हार्ड एंड फास्ट रूल नहीं है यहाँ पर कि आपको सही जवाब ही देना है, राइट? तो एमसीक्यूज की तरफ चलते हैं. तो जो भी हमने कंसेप्ट अभी डिस्कस किया है बेसिकली ये वही है, राइट? तो आई होप आप सबने ध्यान से सुना होगा क्लास के अंदर जो भी कुछ हमने डिस्कस किया है अभी तक. Which of the following best explains enamel's resistance to fracture despite its brittleness? So we have discussed this concept during the lecture, right? So options are high compressive strength, high tensile strength, support from underlying dentine and crystal arrangement. Option D is presence of water and organic matrix. So which of these do you think is the correct answer? So we have discussed this when we are talking about the hardness, right? That enamel is too hard, it has high modulus of plasticity. But then that is high modulus of plasticity means it has high stiffness. But then it has supporting soft dentine or flexible dentine or a dentine which behaves like a viscoelastic tissue, isn't it? So which of these is the correct answer? The correct answer would be option C. isn't it? So option C is the correct answer, isn't it? Try to participate. Nahi Deepa, right? Its compressive strength is definitely high, but the real reason, as we discussed during the session, is that it has high modulus of elasticity, that it has high stiffness, and high stiffness is due to crystal arrangement, isn't it? Its hardness is due to crystal arrangement, and then it is supported by the flexible dentine, that is a viscoelastic dentine, which absorbs stresses and releases them slowly, isn't it? So option C is the correct answer. But very good that you answered at least. तो गलत आंसर देने से क्या फायदा होता है पता है? हमने अपना गलत कंसेप्ट बताया, हमें सही चीज पता चलती है, तो हमारा कंसेप्ट क्लियर हो जाता है. तो इट इज ऑलवेज गुड टू आंसर. अगर आप गलत भी आंसर कर रहे हो तो भी कोई दिक्कत नहीं है, बल्कि अच्छा है, आपका गलत कंसेप्ट जो है वो करेक्ट हो जाएगा, isn't it? So next question, which trace element increases towards the dentino-enamel junction and contributes to acid solubility? So we have just discussed this concept, isn't it? So which of the elements increases towards DEJ and also it increases acid solubility? That is, it increases the caries proneness, isn't it? It makes the tooth caries prone. It makes the enamel caries prone. So which of these following do you think is the correct answer? Is it fluoride, is it carbonate, is it zinc, or is it strontium? So which of these four will make the enamel caries prone or will increase the acid solubility? And the correct answer would be, so which is the correct answer? Deepa, Shweta, which is the correct answer? The correct answer would be carbonate, isn't it? We just discussed that carbonate and magnesium, they increase towards DEJ. Deepa, fluoride increases towards surface. देखो यहाँ पर दूसरा important hint जो है इस क्वेश्चन में वो क्या है? It contributes to acid solubility. That is, it makes tooth prone for caries, isn't it? But fluoride तो हम खुद लगाते हैं. क्यों लगाते हैं? To make tooth less prone for caries, to make it less acid soluble, isn't it? To increase caries resistance. तो फ्लोराइड तो एग्जैक्टली ऑपोजिट हो गया ना जो क्वेश्चन ने पूछा है उसका, राइट? तो फ्लोराइड नहीं, इसका आंसर होगा कार्बोनेट या मैग्नीशियम, व्हिचएवर वुड हैव बीन प्रेजेंट, राइट? Fluoride increases towards surface, Deepa. So let's go to the next question. Why does enamel appear more yellow with age? तो ये भी हमने डिस्कस किया है, more yellow with age. So why does it appear more yellow with age? एज के साथ क्या चेंजेस होते हैं जिसकी वजह से टूथ ज्यादा और enamel ज्यादा येलो हमें दिखने लगता है? ऑप्शन ए इज इंक्रीज इन फ्लोराइड कंटेंट, ऑप्शन बी इज डिहाइड्रेशन ऑफ enamel, ऑप्शन सी इज enhanced light absorption due to structural changes, and option D is increased mineralization, right? तो कई बार क्या होगा कि बहुत ही कॉम्प्लेक्स ऑप्शंस आते हैं, ऐसे में हमें क्या करना है, जो हमने पढ़ा है, जो सिंपल है, जो हमें समझ में आ रहा है, हमें अपनी जेब में से कुछ भी इफ्स एंड बट्स क्वेश्चन में नहीं डालने हैं, ठीक है? जो क्वेश्चन जैसा है, जो ऑप्शंस जैसे हैं, हमें उन्हें वैसे ही पढ़ना है, समझना है और आंसर करना है. तो हमने क्लास में अभी क्या पढ़ा कि जैसे जैसे एज बढ़ती है वैसे वैसे मिनरल कंटेंट बढ़ता है और टूथ ज्यादा यानी enamel ज्यादा ट्रांसलूसेंट हो जाता है. Now when you look at this option C, enhanced light absorption due to structural changes, you might think that yes, it sounds correct. Structural changes हो रहे हैं, mineralization बढ़ रहा है, लाइट ज्यादा उसमें से आ रही है, जा रही है, तो maybe this could be the correct answer. नहीं, हमने क्या पढ़ा है क्लास में? हमने सिंपल सा एक चीज पढ़ी है, increased mineralization. With the age, mineral content increases. That's it. That's all we need to focus on. ठीक है ना? हम डॉक्टर्स हैं, इंजीनियर्स नहीं, तो हमें डॉक्टर वाली सिंपल भाषा ही समझनी चाहिए, राइट? ऑप्शन डी, इंक्रीज मिनरलाइजेशन, दैट इज योर करेक्ट आंसर, नॉट ऑप्शन सी. अनदर हिंट इन ऑप्शन सी इज द वर्ड absorption. Now when we say translucency, when we are talking about translucency, the light needs to be reflected back, not absorbed. If light is absorbed, it makes the tissue appear opaque, not translucent, right? तो हमें वैसे भी ऑप्शन सी को रूल आउट कर देना है, क्योंकि ये गलत है. एब्जॉर्ब नहीं होती है लाइट, रिफ्लेक्ट हो जाती है, राइट? वेरी गुड दीपा. Option D, mineralization. Let's go to the next question. Question number 4. Which of the following best explains enamel's optical birefringence? तो MCQ से ये फायदा भी हुआ, हम ऑप्टिकल प्रॉपर्टीज पढ़ रहे थे और हम बायरेफ्रिंजेंस डिस्कस करना भूल गए. So basically what happens is, let's say this is a tooth, let's say this is the maxillary incisor. Now different parts of this crown would appear different, right? The incisor edge might appear more white and the cervical portion might appear more yellow, right? So basically the appearance of the crown, it would vary from incisal edge to the cervical margin or from occlusal surface to the cervical margin. So different places they appear different. This property is known as birefringence, right? So this property is known as different appearance of enamel at different locations is known as birefringence, right? This is known as birefringence. Now which of the following best explains the optical birefringence? अब इनमें से क्या वजह हो सकती है कि हमें ऑप्टिकल बायरेफ्रिंजेंस मिलता है? तो ऑप्शंस क्या हैं? अमीलोजेनिन रिच स्ट्रक्चर, वेरिंग रिफ्रैक्टिव इंडेक्स ऑफ क्रिस्टल्स इन डिफरेंट डायरेक्शन, porous outer enamel, water and protein content. Now obviously water and protein content won't affect the appearance of enamel. Porous outer layer also does not affect the appearance of enamel. Amelogenin basically is the protein content of enamel, right? It makes up 10% of the protein of the enamel. So again, that can't be the correct answer. So even if we don't know which is the correct option, we can easily rule out the wrong ones, isn't it? So option B, that is, it has varying refractive index from incisal edge to the cervical margin. Now since it has varying refractive index, light would be reflected differently. So somewhere it would be completely transmitted, somewhere it would be reflected back towards you, somewhere it would be reflected away from you. So portions where it is completely transmitted, it would appear translucent. Where it is reflected back to you, it might appear yellowish, and where it is reflected away from you, it might appear more whitish, right? So since it has varying refractive index at different areas, it appears different at different locations, and this is known as optical birefringence, right? So next question. So what is the average specific gravity of enamel? So what is the average specific gravity of enamel? So this we have discussed in the class, in the session, right? And we said that it is approximately 2.9 to 3. 2.9 to 3. So the correct answer would be option C. इसमें तो कुछ भी कंफ्यूज होने जैसा कुछ है ही नहीं, right? Option C is the correct answer here. Deepa, is it clear? अगर कुछ पूछना है तो आप बीच में मुझे रोक भी सकते हैं. कोई क्वेश्चन पीछे देखना हो तो you can ask me to go back, right? Whichever question you want. But let's move on to the sixth question. Which physical property increases from DEJ to the surface? So which physical property increases from dentino-enamel junction to the surface? So let's say this is the dentino-enamel junction and this is the surface of the enamel. So which property increases from DEJ to surface? So in one of the future classes, when we talk about the structure of enamel or the microscopic appearance of enamel, we will discuss about the shape of the rod, and also we will talk about its varying thickness, isn't it? So the thickness of enamel rod is maximum at the surface, and as we go towards DEJ, the thickness of enamel rod decreases, isn't it? The thickness of enamel rod decreases. So basically porosity increases at DEJ, increased porosity, and at the surface the porosity would be low, isn't it? The porosity would be low at the surface, but it would be more at the DEJ, isn't it? So which of these properties would increase from dEJ towards surface? I gave you a hint, and now I hope with this hint you can uh, find the correct answer, isn't it? So option A is organic content towards the surface. Option B is water content. Option C is mineralization and hardness. Option D is fluoride concentration. Now, fluoride concentration cannot be described as a property. Fluoride concentration increases from dEJ towards surface, and if you haven't read the question properly, you might be inclined to mark option D as the answer. So basically, you need to read the question carefully, right? It is talking about a property. It is talking about a property. And though fluoride concentration increases from dEJ towards surface, as the question is asking, it is not a property. So option D is incorrect. But option C, mineralization and hardness, right? Hardness is a property which is dependent on mineralization. So as we move towards surface, mineralization increases. As you can see, the rods are white, and the hardness will also increase. As we have discussed, that the hardness depends on the hydroxyapatite crystal structure or its arrangement, right? So hardness will increase. Organic content and water, these both are present almost at the same place. So wherever organic content increases, water will increase, or you can say wherever water increases, organic content will increase. So option A and B, essentially they mean one and the same thing, right? क्या ये clear है? कुछ पूछना है? Do you need to ask anything? I hope it's clear. So let's go to the next question. And I have a total of 14 questions, right? So we are on the 7th one. What is the predominant mineral content in enamel by weight? Now the question specifies weight, right? And we need to find the concentration of inorganic or the mineral content, right? So I have already told you that inorganic is somewhere around 96% by weight and 88 to 90% by volume. So which of these four options do you think is the correct answer? Deepa, which of these is the correct answer? और बाकी बच्चे भी, श्वेता और बाकी बच्चे, please try to answer, right? So which of these is the correct answer? Since we need to talk about this, since we need to find the weight concentration, it is option C, that is 95 to 96%, right? So next question, question number 8. Which factor makes the core of enamel crystallite? Core of enamel crystallite more susceptible to acid attack. So we have also discussed this, right? Why is the core of the hydroxyapatite crystallite more susceptible to acid attack? Options are high fluoride content. Option B is richness in magnesium and carbonate. Option C is low crystal density, and option D is proximity to surface enamel. Right? Proximity to surface enamel. So which of these four do you think is the correct answer? Is it the fluoride content? Is it the magnesium carbonate? Is it the low density, or is it the proximity to surface enamel? So obviously proximity can't be the correct answer, since we are talking about the core. It has to be deep, isn't it? High fluoride content, again it is more towards the surface. Also fluoride makes it caries resistant, not prone. So again option A and B can be ruled out. Now low crystal density. Crystal density is almost uniform throughout, right? Its orientation might change. So we'll discuss that when we will be discussing about the microscopic structure, right, in one of the future classes. But for now you can say that the crystal density is almost same. And we have also discussed this thing when we were talking about the substitutions, right? So there, what did I tell you? That apart from fluoride, there are two other ions which increase the caries susceptibility, and these two ions are magnesium and carbonate, which are rich in the core of the hydroxyapatite crystal, isn't it? And that's why we have also given it a specific name, because of the rich carbonate content. What was the name? The name was carbonatoapatite, isn't it? Carbonatoapatite, isn't it? Carbonatoapatite. Right, Deepa? So option B is correct. Not C, not A. It is the option B that is correct, right? Fluoride, बहुत सिंपल है ना. अपन ने डेंटल कॉलेज में जब हम थे पढ़ाई कर रहे थे, तब हमने लगाया भी होगा, जब आपकी कम्युनिटी पोस्टिंग होगी, जब आपकी पीडीओ पोस्टिंग होगी, तब आपने फ्लोराइड एप्लीकेशन भी की होगी. So we need to focus on these keywords, isn't it? We need to focus on the hints of the question. Obviously, fluoride does not increase susceptibility to acid attack. It reduces the susceptibility, right? We use it as treatment, isn't it? So option A can't be the correct answer. So let's go to the next question. What is the average refractive index of enamel? So refractive index क्या है enamel का? We have just discussed it, isn't it? Refractive index of enamel is 1.62, isn't it? Enamel is translucent and its refractive index is, refractive index is 1.62, isn't it? So simple question है ना? Let's go to the next question. So enamel has a bluish tinge at incisal edges because ये भी मैंने तुम्हें अभी बताया है थोड़ी देर पहले कि enamel जो है newly erupted, जो incisal edges होती हैं वो हमें ब्लूइश दिखती है पर्टिकुलर. और क्यों दिखती हैं वो ब्लूइश? क्यों दिखती है हमें ये ब्लूइश? ऑप्शंस क्या है? ऑप्शंस क्या है? थिकर एनामल लेयर, हाई फ्लोराइड कंटेंट, रिफ्लेक्शन फ्रॉम डेंटिन एंड डबल एनामल लेयर विदाउट डेंटिन बीनीथ. तो व्हाट डू यू थिंक इज द करेक्ट एक्सप्लेनेशन ऑफ दीज फोर? थिकर एनामल लेयर होती है क्या? एनामल लेयर थिक, यस इट इज थिक. So the statement is true, but is it the correct explanation for the question? High fluoride content. It is a newly erupted tooth, and even if it was not a newly erupted tooth, yes, fluoride content might be more. But is it the correct explanation for this question? Reflection from dentine. So had it been a reflection from dentine, would it appear blue or would it appear yellow? तो ये क्वेश्चन तो ये ऑप्शन को हम वैसे ही रूल आउट कर सकते हैं, isn't it? ऑप्शन सी, क्योंकि light is not getting reflected from dentine. Had it been getting reflected from dentine, it would appear blue, yellow. As I have told you that there is no dentine beneath the incisal portion of the tooth, right? There is no dentine beneath the incisal portion of the tooth. तो डेंटिन तो यहीं पर ही रह गया है ना, डेंटिन तो ये नीचे ही रह गया. और ये ऊपर क्या है हमारे पास? लिंगुअल एंड लेबियल लेयर्स ऑफ इनामल, isn't it? So basically it's a double layer of enamel. तो डबल लेयर ऑफ इनामल है, नीचे कोई डेंटिन भी नहीं है. So total light is getting transmitted through the enamel and we can see that blue fluorescence. So the double layer of enamel without dentin beneath, that is the main reason it appears bluish. So let's go to the next question. I hope it's clear, right? The permeability of enamel increases in which direction? तो permeability किस direction में increase होगी? Let's say this is a tooth. Cervical margin है, occlusal portion है. So surface to DEJ, DEJ to surface, incisal to cervical, buccal to lingual. So which of these do you think is the correct answer? Permeability of enamel increases in which direction? So while explaining one of the previous questions, I have discussed this concept as well, isn't it? In which direction does it increase? From surface to DEJ or from DEJ to surface? The porosity is more towards the DEJ, isn't it? The porosity is more towards the DEJ, isn't it? So permeability will also increase from surface to DEJ. That is option A, isn't it? So porosity or the permeability will increase from surface towards dentino-enamel junction, right? Let's go to the next question. What happens to enamel's translucency upon dehydration? So we have discussed this concept as well. Upon dehydration, the tooth becomes more opaque, and upon dehydration, the tooth again becomes translucent, isn't it? So during acid etching, when the tooth is dehydrated, it becomes opaque, right? But when you rehydrate the tooth, it again becomes translucent. So what do you think will happen when the translucency What do you think will happen to enamel's translucency upon dehydration? Will the translucency increase or will it decrease? The correct answer would be it decreases, isn't it? Translucency decreases, or you can say the opacity increases, right? Opacity increases or translucency decreases. So let's go to the next question. Which statement about water in enamel is true? हमें water के बारे में true statement ढूंढना है, right? Accounts for 10% by weight. So do you think water by weight accounts for 10%? ये हमने पढ़ा है ना कि water by weight accounts for approximately 4%, or you can say 3%, isn't it? It is 3%. Water by weight makes up 3%. Occupies pores less than 5 nanometer between crystals. So when we were talking about the hardness, I do these crystals, right? I do these crystals, and I told you that there is some space between these crystals, right? And this space is less than 5 nanometers, and if this entire structure is inorganic, like if this entire structure is inorganic, then what do you think is the tissue intervening this inorganic content would be called? It would be either organic or water, isn't it? It would be either organic or water. So basically this 5 nanometer space is occupied by the organic and the water content of enamel. So option B is the correct answer, isn't it? Option B is the correct answer. Confined to prism sheaths only. So again this is incorrect. Prism sheath means it is present in the rod sheath. Prism sheath or rod sheath is one and the same thing. So this is basically enamel rod, and a space between two enamel rods, that is what the rod sheath means. So it is not just confined to rod sheaths, but this entire rod is made up of several hydroxyapatite crystals, and the water is present between these hydroxyapatite crystals as well, isn't it? So basically water is present in more than one places. Also, if there is a defect in the enamel, in that defect as well, water would be present. Any crystal defect is there, water would be present, isn't it? So water is present at least in 3 places. So option C is incorrect, option A is incorrect. Absent in the surface enamel, again this is incorrect. Water is present everywhere. It's just that we can't see it, isn't it? So water is present everywhere. It is even present in the surface layer. Question 14. Question 14 is in molars, enamel is thickest on which surface and why? So where is it thickest and why? So we have discussed this when we were talking about thickness. When we were discussing the thickness of the enamel, I told you that it is thicker on the supporting cusps and it is thinner on the guiding cusp. So which is the supporting cusp? That would be your answer, isn't it? So option A, what does it say? Lingual of maxillary or palatal of maxillary, is one and the same thing, right? And buccal of mandibular, because they are the supporting cusps. That is, they are load bearers. Option B, it says buccal of maxillary, this is the guiding cusp, and lingual of mandibular, again the guiding cusp. And because it is a non-supporting cusp, so obviously this is the incorrect statement, isn't it? It's incorrect because we have already discussed that the guiding cusps are a thinner layer of enamel as compared to the supporting cusps. Cervical area, root protection, again this is incorrect. We have studied that at the cervical margin, it's the thinnest and the thickness is approximately 0.7 millimeters. Interproximal surfaces to resist caries. We have again discussed that on the proximal surfaces or on the buccal or lingual surfaces, the thickness is approximately 1.3 millimeters or 1.5 millimeters, isn't it? So again, option D is incorrect. So option C, D and B are incorrect. So which is the correct answer? The correct answer would be option A, right? Option A is your correct answer. Is it clear? So is there anything that you would like to ask? Is there anything that you would like to ask? So before we end, I would like to tell you that tomorrow you are going to have oral surgery session, right? So tomorrow you will have the oral surgery session. So is there anything that you would like to ask? Deepa, Shweta, बाकी बच्चे क्या आप लोग कुछ पूछना चाहते हैं? So do you want to ask anything? कोई कंफ्यूजन है, कोई डाउट है? यहाँ क्लास ओवर करें. तो अगर आप लोगों को कोई डाउट नहीं है तो फिर हम क्लास ओवर करते हैं और मे बी विल मीट नेक्स्ट सैटरडे, राइट? सो टेक केयर, गुड नाइट एंड प्लीज रिवाइज व्हाटएवर वी हैव स्टडीड टुडे. ठीक है, तो जितना रिवीजन करोगे उतना ही कंसेप्ट्स क्लियर होते जाएंगे. ट्राई टू सॉल्व एज मेनी एमसीक्यूज एज यू कैन, राइट? तो अभी हमने थोड़ी सी देर में 14 एमसीक्यू सॉल्व किए ताकि जो कुछ भी हमने पढ़ा उसे हम रीइंफोर्स कर सकें. सिमिलरली ट्राई टू सॉल्व एज मेनी एमसीक्यूज एज यू कैन फॉर एनी सब्जेक्ट, व्हिचएवर सब्जेक्ट यू आर स्टडीइंग, राइट? तो जितना एमसीक्यू सॉल्व करोगे उतना ही वो सब्जेक्ट रीइंफोर्स होता चला जाएगा, ताकि एग्जाम के दिन तब कोई हमें सरप्राइजेस नहीं चाहिए, राइट? सो सॉल्व एज मेनी एमसीक्यूज एज यू कैन. ओके, ऑल द बेस्ट.